Hi, and welcome to the good stuff that I've been doing. Today in this video, we're going to discuss the trigonometric identities and the trigonometric functions. So let's begin with the trig functions. The trig functions are defined as follows. The sine of the angle theta is given as the opposite over the hypotenuse. This means that if we have a right angle triangle, this is angle 90 degree, our right angle triangle, then the sides labeled are A, B, and C. Usually, the way the labeling is done is that the angle, let's say an angle is here is theta, then this side is now our opposite, and then this side is now our adjacent. The longest side in the triangle is always described as the hypotenuse. On the other hand, if assume that the angle, let's say the angle theta is over here. So in this case now, this side facing the angle, which is side B, will be our opposite. Then the hypotenuse is always fixed, but this would then be our adjacent. So this is how we define the labeling in a triangle for right angle triangle case. But whatever label we may use, sine of theta is defined as the opposite over the hypotenuse. So in this case here now, for this triangle, sine of theta would be equal to the opposite here is A. Let's say this angle is theta, let's say. Then the opposite is A. Then the hypotenuse is C. Then the cosine is defined as the adjacent over the hypotenuse. So the cosine of theta is the adjacent being A, not being a B, then the hypotenuse is C. And then the tangent of theta is defined to be the opposite over the hypotenuse, over the adjacent, the opposite over the adjacent. So the opposite being A and the adjacent is B. Now, when this is all said and done, we have to describe the inverse, not really the inverse, but as just like the fractional. Let's say if we have a sine theta, then the 1 over sine, which is the inverse of sine, but not the inverse sine, but just the inverse of sine, is defined as cosecant. And so in this case, cosecant of theta would be, then in this case, sine theta being A over C, cosecant of theta will be C over A. And then cosine is defined, 1 over cosine, which is the inverse cosine, is defined as secant. So in this case, secant of theta would be C over B. And then cotangent, obviously, would be B over A. So when our trig functions are defined, we revisit our Pythagoras theorem, which tells us that in any right angle triangle, the square of the hypotenuse is the sum of the squares of the other two sides. So in this case, if we take the hypotenuse all squared and we add this together, this is what is going to equal. We are going to get the square of the hypotenuse. So usually the way we derive identities relating this triangle is as follows. Given that C squared is A squared plus B squared, what we'll do, we can like divide both sides by C squared at first. So when we divide both sides by C squared, let me make the light a little bit thicker. So when both sides divided by C squared, we'll have that 1 is equals to, let's say, C squared over A squared, or no, A squared over C squared plus B squared over C squared. So this means that 1 is equals to A over C all squared plus B over C all squared. Now notice here for our case that A over C is sine and B over C is cosine. This tells us, let me rule a line here. This tells us one thing, and that is that this sine squared theta plus cosine squared theta is equals to 1. So let me change it. Okay. So this tells us that sine squared theta plus cosine squared theta is equals to 1, because A over C plus B over C, both squared, is equals to 1. Now, when we divide by C squared, what we can do next is to divide by A squared. So when we have C squared being equals to A squared plus B squared, we can divide by A squared to obtain C squared over A squared equals to 1 plus B squared over A squared, or we have C over A is all squared is equals to 1 plus B over A all squared. So what is C over A? For our definition, C over A is cosecant. So in this case, cosecant squared plus is equal to cosecant squared theta is equals to 1 plus. Now, what is B over A? Cotangent squared theta. So this is another identity that we have obtained. Let's go and see what other identities that we can derive. Okay, let me change the color here. Now, let's say we have C squared is equal to A squared plus B squared as follows. We are divided by C, we are divided by A. Let's divide by B. Then this is C squared over B squared is equals to A squared over B squared plus 1. Now, what is C over B? C over B is one of our cosines. So that is okay, no, C over B. That should be cotangent, right? Yeah. Where do we define C over B here? What we define here is B over C. Okay, if we define cosine to be B over C, secant should be C over B. So this was supposed to be a B. That was a mistake from my side. So this is secant squared theta is equals to A over B should be tan. Okay, A over B squared. So this should be cotan. So A over B should be tan. Yeah. So this is tan squared theta plus 1. Or usually we write this as secant squared theta is equals to 1 plus tan squared theta. So here we have obviously done something interesting. What we have done is that, okay, wait, let me see. What we have done is that we have proved these identities here. Let me stamp them for us. So this is the first one, this is the second one, and this is the third one. Now we can collect these identities and probably pile them up. So let's see, we have proved that sine squared theta plus cosine squared theta is equals to 1. And then we have proved that cos x squared theta is 1 plus cotangent squared theta, and then secant squared theta is equals to 1 plus tan squared theta. Now, for here, we are going to end this chapter. In the next video, what we are going to concentrate on is solving problems related to trigonometric identities. Our focus specifically will be on proving and deriving several identities. So thank you for watching, and please subscribe to the channel. Thank you, and I appreciate it. Okay, bye.